So the second speaker is ModAH2. He is a researcher at the University of Copenhagen, Denmark. And today he will talk about the influence of underlying ecological processes on ASF spread models. The floor is yours, ModAH.
Thank you very much, and thank you for the nice introduction. Can anybody hear me? Everybody?
Yes, I hear.
Yes, excellent.
We don't see your slides though.
Excellent. Wow. How about now?
Yes, thank you.
Okay. So I'm a PhD student here at the University of Copenhagen, and my project is on basically making an interface between wildlife, wild boars, and domestic pigs in Denmark, and modeling the interplay between the disease between those two distinct populations. So this work that I'm going to present today is about that. So we have the two populations, domestic pigs and wild boars. And to start out with, we have the land usage to figure out how many resources there are available for the wild boars in Denmark. One can get these in almost arbitrary resolution. So for the Corine land usage, we get these down to 100 square meters. But for our purposes of modeling wild boars, we have aggregated these land usage data into hexagons of 2 kilometer width, and this is because this roughly translates to the home range of a wild boar group. To facilitate this aggregation and to make pointy and map accurate hexagons, we are developing an R package called Hexscape that you are more than welcome to try out if you have similar needs as we have. Today I'm going to be talking about the wild boar models and the ecological models that whether or not misspecification in these have an influence on the spread of ASF and ASF-like diseases. So this is why I'm diving very narrowly here into how the setup for the wild boars is done. So let's take a very narrow view on a closed view on southern Jutland. This will be the area where I'll be talking about more and more. As you can see by the intensity of the color, this shows that in most of the patches that are in Denmark, you don't have a high carrying capacity for pigs, but there are still some regions where a population could be sustained. So the setup that we are going to look at today is how one specifies these ecological processes. So we have come up with a terminology that is either you specify the ecological part of the model by being outcome focused or by being process oriented. And by that, we can mean many things, but specifically for this case, for instance, when one is specifying the mortality process in the wild boar model, one can parameterize this by only taking parameters that comes from field studies that say, okay, piglet mortality is very high, but then if the pig survives this, then the general mortality afterwards is low. So the mortality in such models will be basically only dependent on the demographic that the pig is from. And but a process-oriented one would. A process-oriented ecological model would also try to encompass things that we might not have so much data on. For instance, the effects of seasonality and the effect of the number of other pigs in the same area or the same places. So between the outcome-focused model, we have also the pigs that disperse in the landscape when there are too many of them and not enough resources. For the process-oriented one, we are not only depending on the resources of whether or not a new patch will be colonized by wandering pigs, but also whether or not the ratio of pigs of boars to sows matches up with the incoming group. So this is a density-dependent component also in the dispersal. So specifically, to illustrate the effects, we have an ASF-like disease. So we have done with the mortality. We're just marking them as recovered, we have equipped this disease ASF-like disease model with two infection components. One that is a density-dependent infection component, and one that is a frequency-dependent infection rate. So what this means that ASF only depends on the density, but if one could say that there are too many possible interactions within a group because the size is unlimited, we might have even more infection coming through that we might not be seeing otherwise. But here specifically, we are going to just be looking at how the spread differs in the two cases just by having a density-dependent effect or not. So a little bit about the technicalities with the setup. The implementation is done using a programming language called Rust, and it's built on top of an ECS, an entity component system called BEVI. There are very nice reasons why I have chosen this particular ECS system and this particular programming language, if people are interested in this. But I would like to say just a few things about ECSs. So ECSs can be thought of as if you have a data frame in R or something like that, then an entity is the row, it's the observation, a component is the column, and the system is the grouping of these that yields a new state. And why does it have new names? And it's because vectors and arrays in computer science serves one purpose, and it's that to have an extremely efficient access pathway to one element at a time. And data frames, the innovation that data frames came up with is that it yields the same efficacy of accessing one element, but for an entire column if you operate with columns as your variables. And ECS facilitates the efficient operation and access to a stub of data. So an agent, a multifaceted agent, is a stub of data, and that ECS facilitates operating on such agent. So the aim of the work that I'm working on right now is to both study the differences in spread velocity between the two approaches, and study the robustness of the population model if let's say we choose a control scheme that says call all the wild boars in northern Jutland. How does this affect the system? So the ecological system, the system that governs how the wild boars evolve in the landscape, has to be robust under such extreme interventions. And also, what's the effects of all of a sudden either some patches are overpopulated or underpopulated. But for today, I think we're just going to look at the spread velocity, as there's enough to talk about there. So I have some scenarios I would like to show you. These scenarios are seeded in the area that I have marked here on my map. So this map shows the carrying capacity. So if there were pigs, one would expect the nominal population size to be around that carrying capacity, more or less bigger or smaller, depending on when reproduction has occurred in the year, etc. The infection is seeded in one animal somewhere. The simulation is ran for 50 years. And so that's not really important. It's just to show you the long tail behavior of the simulation in this scenario. Furthermore, we start out the simulation. We seed the infection once the wild boar population have reached some sort of equilibrium in terms of populated patches. Let's look at some outputs. This is the outcome focused one, right? So I'm going to turn this on. So these colored patches here shows the population of pigs without an infection, and these are cumulative infected patches. So whenever a patch is infected once, it stays marked for the duration of the simulation. And the picture on the right is the carrying capacity. So this shows you where there could have been pigs in the landscape. And so yeah, this is 50 years. So I shouldn't talk for more than 50 years. So what you can see here is that the number of infected patches is sort of sporadic and goes in all direction. In the outcome focused one, where we don't have any density dependent effects. And if I do the same with the process oriented one, so you see that there is an equilibrium of pigs in the landscape, and there's a lot. Even in areas that wouldn't have been so perfect, but there are. And the number of populated patches is very predictable, very local, and spreads very slowly. So this is a huge concept. This is a huge difference in how ASF spread is behaving, and it's sort of a very important point. So yeah, the results, the outcome focused one is very unpredictable. It went in all directions and in different velocities. And the density dependent one, it's more or less, even though there are a lot of pigs in the landscape, it wasn't all of them that got infected simultaneously or as sporadically. So a little bit of discussion on these points. So all right, so I'm certainly preaching for a process-oriented approach, but first of all, there's not a lot of available data. So the time. So what to determine what process to endow your ecological model, it takes research and care into deciding that. And upon deciding which processes to include, there aren't any data to inform the parameterization of such, and thus manual calibration is almost necessary. Whilst with the outcome-focused one, those problems are not present. But on the other hand, you have sensitivity to misconfiguration. If you initialize the process with too many pigs, opposite to the map that you have chosen, the spatial configuration you have chosen, then I could have shown this, but it's fairly obvious that there's nothing to sort of ensure that we go back to a sensible equilibrium immediately. And also, again, if I try to call a herd or artificially inject some pigs into the process, they don't stabilize as fast in an outcome-focused one, because it sort of assumes the steady state. Okay, I also wanted to say a few things about why I'm using an ECS, and it's because I think with agent-based models, there are a lot of advantages to using them, and but a lot of the disadvantages are purely computational. The number of actors, coding processes that overlap, is very complicated, and recording the simulation state at different levels. So sometimes you want to record the individual pigs, sometimes you want the grouping, sometimes you want the pigs that live in a place that have domestic pigs. So the interface are all should all be very easy to interject recordings into, and basically ECS attempts to address this in a sort of generic way. So so in ECS allows me to have a network relation on dynamic agents throughout the simulation. Okay. The future work will be spent on exploring the two other aims that I have posited, and also try to put in the domestic farms and explore types of interfaces that there could be between those two, and explore the efficacy of surveillance and control schemes that use both information from both populations simultaneously. Right now, we have things for wild boar and we have things for the domestic pigs, but usually whenever an outbreak really happens, then there's a joint strategy, and it could be nice for decision support if our simulation models could encompass this. Thank you for your attention. I have heard some very interesting talks and some very interesting thoughts throughout the day, so I'm sure there is some interest, and I would love to hear your thoughts, ideas, or anything to that matter to this project. Yeah. I think my 15 minutes is out.
Thank you, Mossa, for a very interesting talk. Let's see, do we have any questions in the audience? Otherwise, I have a couple of questions. I cannot see any questions in the chat. But
I would also like to say that this is a lot of this is work in progress, and it's already showing quite promising results. So, yeah.
That's very interesting. Yes, Pauline has a question.
Thank you. Thank you, Mossa, for the talk. It was very interesting to see where you consider the including space into the model. I'm not sure to have fully understood the difference between the two approaches, so the process-oriented and the outcome-oriented, because the difference you observe between the two systems, could it be related to a difference in calibration or not? And so does it really represent the same spatial dynamics? And also, could you say a bit more about computing efficacy between the two approaches?
To be very specific about this, the two models or the two approaches are the same in that the process-oriented one still uses the same baselines and still uses the same considerations for the resources. But in the event that there are a surplus of individuals that goes against the carrying capacity we have found through the Corine land cover data, this is penalized by more severe mortality, lowering the survival parameters, and rejecting to colonize new cells because the numbers don't add up. So it's not like the process-oriented one differs that much from the outcome-focused one, and it's just that the carrying capacity we started out with positing, if that's violated, then there are consequences to it. And these consequences, they shouldn't manifest themselves in the spread model, because the way that the spread models are set up is independent of how the ecological model was set up, but the ecological part of the model should respond with the disease, right? And there's no linking between these things are still very separate. I think the computational efficiency, I would like to know what you really want to know here, then I will answer.
Because it's a different way to consider the two processes, so I was wondering if there is a cost in terms of computing.
I haven't actually measured this, so I don't want to say anything, but it's basically the same model with more terms in where the decisions are being calculated. So there aren't. I had no reason to measure the difference.
Thank you. Elisabetta?
Hi, thank you for your presentation. I would have just one small question and maybe a detailed one. I'm not sure I understood when you make the simulations. What you showed, at least it was with a start in the way you started always at the same place. Is it different if you initiate if you seed the simulation in other places, or it was a reason why you started always? Maybe you already said it and I didn't understood it. Sorry.
It's a very good question. If this was another country, I would have started it in multiple different places. But I just saw a cluster on this map of good patches to start a population in that will be sustained. So I didn't want to have issues with the wild boar population to start with. I wanted to have, for most iterations, a flourishing wild boar population, and then see what the disease says, what the disease spread says. And I don't have many options in Denmark, so I started here because I saw some.
Okay.
Yeah. Sorry.
Okay. Thank you.
Yeah.
Any other questions? I have one. I was just curious about so the agent base. It's one wild boar. It's not the group.
I have different groupings. The ECS facilitates the networking between them. So I have individual wild boars, yes, and they experience the disease individually. The movement is in groups, and the dispersal is in groups, but it's individual dams that have piglets.
Right.
So it's a whole thing.
Yeah.
Yeah.
You mentioned something about that you needed more type of data to when you talked about this OP model. What type of data do you need?
So, for instance, if I tried to look at everything under the sun for classical swine fever and African swine fever modeling, and how far a pig travels is basically not. I mean, there's some GPS data that suggests males, they travel for 100 kilometers before they settle a new place, and sows doesn't. And then you find some other papers that says sows also travel 100 kilometers if they need to. And how this process is parameterized, that's the data I would like to have. Like, is it a species specific? Do I need to, or is it just because of the way that the resources are scattered in Denmark, where you have more flatlands and arable land, and not so much forest? Like, I don't know these things. I can only try. So I can make sure that my models has these things in it, and then I can see what happens if I had endowed it with this kind of process or that. But I don't know for Denmark if the pigs travel far or they don't. Yeah.
Okay, thank you. I also had a question about that hex scope. It was an R package.
Yes.
So is it on cron, or
no, we're actively developing it, and it's on GitHub, but it's very usable, and the more use cases we have for it, we will accommodate those.
Very useful.
Yeah.
Okay. Thanks, Mossa.
You're welcome.
Any other questions? I cannot see any hands up, or I don't think there is anything in the chat either. So thank you, Mossa, once again for a very nice talk.